Alright, question 5. And here we're dealing with another graph question. And this is an exponential, and we'll be working with some logarithms as well. Alright, so again, I don't know if you can see well what is written here on the resolution, but I'll read it out and please follow along on your own guides or your own exam question papers. So we have here question 5. Sketched below is the graph of f of x equals k to the x, an exponential. And the point 416 is on the graph, and there we can see it cuts the y-axis at 1. So question 5.1. 5.1 says determine the value of k. So let's just start. We've got given the function f of x equals k to the x, and we have to find the value of k. So what we can do is we can just substitute a point that we know that we have on this graph in. So let's use the point. There's the point 416. So we'll say that means that y is 16 when x is 4. And then we can get the prime factors of 16, which is 2 to the power 4. That'll equal k to the power 4. And we can say, therefore, since the exponents are equal, therefore the bases are also the same. So 2 equals k. And there's our answer to question 5.1. So let's maybe just write down the equation now that we have k. So f of x is equal to 2 to the power x. So there is our equation. Alright, let's look at 5.2. So 5.2, what is our question there? Let me just rewrite that. 5.2. So our question says the graph G is obtained by reflecting this graph about the line y equals x. Now we need to determine of the new equation in the form of y equals. So this one that we started with, y equals 2 to the power x, that is now reflected in the line y equals x. Alright, so what we need to do is we need to swap x and y, because y equals x and x equals y. Simple, right? So we'll just say x equals 2 to the power y, and now we need to get y by itself. So the easiest way to do that would be to take the log of both sides. So log of x equals log of 2 to the power y, and we did that so that we can use this property of logs, where the exponent can move to the front to turn an exponentiation question into a multiplication question. Alright, and now we just need to divide both sides by log 2. So we'll get log x divided by log 2, that equals y. And what do we know? What does this mean? If we've got a log of something divided by something else, then we know it's just that the bottom one just becomes the base. So we've got log x base 2 equals y. And in the exam, I'd suggest if you have a y equals something, write it on the left hand side like y equals log x base 2, just to make sure we don't upset the marking people, because it says y equals on the left in the question. Alright, question 5.3. 5.3. We are asked to sketch the graph of G and indicate on our graph the coordinates of 2 points on G. Alright, so this is what we need to sketch. That is G. This is G. Alright. Let me rewrite that. Might not look like a G. Okay, so this is graph G. Alright. Now for 5.3 we need to sketch that. So let me draw a system of axes there. Y and X. Y and X. And if y equals x and x equals y, we know all that means is our original graph, the x and the y just swap around for the points as well. So we had a point here, the point is 0, 1. So if we swap 0, 1 around, we get 1, 0. So we can do point 1, 0. Okay, let me just draw the graphs along. So we get the point 1, 0. And we have another point that was 4 and 16. Those will swap around, so we have a point 16 and 4. So easy as that, right? The graphs just swap around if we do a reflection in the line y equals x. Alright, And there we have it, 2 points are given. Great. Then we can move on to question 5.4. So question 5.4, and we have 5.4.1 to start with. So this says, use your graph to determine the values of x for which, and this one, I'll just write it down, f of x multiplied by g of x must be greater than 0. Alright, now the best way to answer these questions is to think about the following, about the signs. If we have a plus times a plus, plus times a plus, let me write that in brackets, I think that'll look a little bit better. Right, a plus multiplied by a plus, we know that is equal to a plus, right? Positive, positive gives positive. Positive times a negative, that gives a negative. And a negative times a negative gives a positive. So the important thing here is to look where are both graphs positive or where are both graphs negative, because that will give us something that's bigger than 0. Alright. I'm just going to draw the initial graph on this one as well for you to see. So the initial graph looked something like that. Alright? Something like that. So now we need to check where are these graphs positive or negative. The best way to visualize this to indicate all intercepts with the axes. Alright, or at least with the x-axis. So here is one spot. And so we can look at everything, and here's an asymptote, so that's also an important one to look at. Alright, so we can look at everything to the left here, everything in here, and everything to the right here. Okay, everything to the left, one graph here is positive, so we've got a positive, and the other graph is undefined here, undefined. So we cannot have a positive and positive, positive, negative. One of them is undefined, so this we can cross out. Nothing happens there. What about this little spot here? One graph is positive, it's above the x-axis. The other graph is below the x-axis, negative. So here we've got a positive and a negative, which gives us a negative. So that is less than 0. So that one we don't want either, and we can cross that out. Then we're left with this part, where one graph is above the line, positive, the other one is also above the line, positive. So we've got a positive and a positive, which gives us a big positive for this section. So that is it, everything to the right of 1. So our final answer would be x must be greater than 1 for the two graphs to both be above the x-axis. And there we go, 5.4.1. And I know that looks ridiculously ugly at the moment, but you follow me while we're going through it, right? Then we're going to look at question 5.4.2. So 5.4.2. Here we get told we need to solve for x, find the values of x for which g of x is less than or equal to -1. Alright, now since it's a sketch that we have here, our graph is not accurate. It's just a sketch that we're asked to do, so we can't read off the exact values. But let's do the sketch and just see roughly what we're looking for. Alright, so this was our graph, and here we had the point 1 on the x-axis. Okay, so we asked, where is this graph G? Where is it less than or equal to -1? So that means you're at -1 somewhere. We're going to need to find that value. So all of this will be the answer, this section here. Right? So between 0 and that value. That'll be the answer. Now let's see how we find that. So g of x is this equation here. So we'll have log of x base 2 must be less than or equal to -1. And let's write the other side in a logarithmic form as well. So you've got negative, and 1 is always just log of something with its same base. So log of 2 base 2. And let's rewrite it one more time to do that. Log base 2 of x less than or equal to log base 2 of 2 to the power negative 1, right? We can take the coefficient and make it into an exponent. And now that we have log with the same base on both sides, what we can do is we can ignore the logs. So we can say that means 2 to the power, not 2 to the power. That means x must be less than or equal to 2 to the power negative 1. And that is 2 to the power negative 1 is the same as 1 over 2. So there we go. And that looks about right. 1 over 2, a half. So if x is less than a half, but what else do we need to remember about logarithmic inequalities? Well, that's right. We cannot have log of a negative number. So this guy must also be greater than 0. Log of whatever we have there. So we also know that x must be greater than 0. So we combine these two into our final answer of x must be greater than 0 but less than a half. And there we go. That's our final answer. Perfect. Last question to go, and that is question 5.5. And let's do that one in red. Alright. Let's do this one. We haven't used this color yet. So question 5.5. 5.5. We are told that h of x is equal to f of negative x. Right. And if that is true, so let's write down what h of x is then. So if f of x, not that one. F of x equals 2 to the power x, then h of x will be 2 to the power negative x, right? Because h of x is f of negative x. Alright, now the question says we need to find x, or solve for x when this is true. If f of x minus h of x is equal to 15 over 4. Okay, so all we need to do is substitute this in. So f of x is 2 to the power x minus, and h of x is 2 to the power negative x. 2 to the power negative x equals 15 over 4. And now, I don't like the negative exponent, so I'm going to change that into a positive. And how do we do that? By just taking it to the other side of the line. Equals 15 over 4. And I don't like the fractions, so I'm going to multiply everything by 2 to the power x. So 2 to the power x times 2 to the power x is 2 to the power x squared. Minus 1 equals 15 over 4 times 2 to the power x. Alright. Let's continue. Now we still need to get rid of this 4 because we don't like fractions, right? So multiply everything by 4. So that'll give us 4 times 2 to the power x squared minus 1 times 4 is 4 equals 15 times 2 to the power x. Great. And now we can see this looks like a quadratic trinomial. So let's rewrite it in the form that we're used to. So 4 2 to the x squared minus 15 times 2 to the x minus 4 equals 0. Alright, and now we can factorize. So the factorizing, we'll just do big bracket and another big bracket equals 0. So 2 to the x, that is the same as our usual x value, right? So we'll have 4 times 2 to the x, and on this side just 2 to the x. So these two things multiply together give us that part. And then we need to get the factors of 4, so we can have negative 4 times positive 1 will give us negative 15. Alright, and let's just for interest's sake, let's do another method of factorization in case we couldn't just see this straight up. Let's say we want to use turning this into a grouping question. Okay, then we could say take the coefficient of the first number of the squared and the coefficient of the constant, or just the constant, and multiply them together. So 4 times 4 is 16. Now we take all the factors of 16. So that could either be 1 times 16, or 2 times 8, or 4 times 4. And we need to get a 15, a negative 15, right? So which thing here will give us negative 15? Well, it'll be negative 16 plus 1. That'll give us negative 15. So that's what we'll use. So instead of the negative 15, we're going to rewrite this as 4 times 2 to the x squared, and then plus x, sorry, not plus x, plus 2 to the x, 1 times 2 to the x, minus 16 times 2 to the x. And then minus 4 equals 0. Now we can do grouping. So we can do the first two and the second two. So if we factorize here, we can take out a 4 times 2 to the x, and what's left is a 2 to the x plus 1. Alright? And we don't take, sorry, my bad. That is very wrong. Okay, so what we can take out here is just a 2 to the x. We can take out a 2 to the x. What's left is 4 times 2 to the x plus 1. And here we can take out a negative 4. And what's left is 4 times 2 to the x plus 1. Alright. And so now this bracket is the common thing. So 4 times 2 to the x plus 1. And what's left is this 2 to the x minus 4. Alright, equals 0. So here we have the brackets, and we see it's exactly the same as this side. Perfect. So now we can continue to solve for x, and this means that this bracket is 0 or this bracket is 0. So the left, we've got 4 times 2 to the x plus 1 equals 0, or 2 to the x minus 4 equals 0. So we can take over the negative 1 and then divide by 4. So we've got 2 to the x equals negative 1 over 4, and that's impossible. A positive number raised to a power cannot become a negative as an answer, so that's not possible. On this side though, we can have 2 to the x equals 4, and then 4 can be written as 2 squared. And since the bases are the same, then we know therefore our exponents are also equal, and x equals 2 is our final answer. And that is it for this question. Please let me know if there are any mistakes or any comments that you'd like to make, or any other ways that you solve the question. Thank you.